This video focuses on how we can determine if a table counts as a linear function. First, we need to know the definition of a linear function. A linear function is any function that graphs to a straight line, or in other words, when we create graphs, if the function makes a straight line, we would call it a linear function. The straight line that we see is the result of a constant rate of change. And one way we can determine if tables are linear functions or not is to measure the rate of change and see if it does stay constant. So for our example here, we see the question asks us to determine whether each table represents a linear function. First, we're going to look at the blue table. If it's going to be a linear function, we need to see that y and x move in the same ratio together or at a constant rate of change. So the first thing we can see is the x values on the left from the first point to the second point. We see that x goes from 0 to 2. That increases by 2 units. And when x increases by 2 units, the y goes from 6 to 12. That's an increase of 6 units. So the y goes up by 6 units, and during that time the x went up by 2. We could say the slope, or the rate of change during that time, is 6 over 2. Now we're going to look from the second data point to the third data point. The x goes from 2 to 5. We go up from 2 to 5. That's an increase of plus 3. And during the same time, the y value goes from 12 to 21. That's an increase of plus 9 to get from 12 to 21. So we could say at that time, y went up by 9 as x went up by 3. And from the third to the fourth row, we see x goes from 5 to 6. That's an increase of plus 1. And we see that the y, during that time, the y went from 21 to 24, an increase of plus 3. We write that as a ratio, 3 over 1. And we see something. 9 divided by 3 is equal to 3 over 1. 6 divided by 2 is also equal to 3 over 1. We see that the rate of change here, how much y changes compared to x, remains constant each time. So we could say that the blue table is a linear function because it has a constant rate of change. Now let's look at the red table. First, x goes from -4 to -2. If we go from -4 to -2, we've increased by 2 units. And the y goes from 6 to 7. That's an increase of 1 unit. If we wrote that as a ratio of change, the y goes up by 1 as x goes up by 2. We then see again, x goes up by 2 units, and y goes from 7 to 8. That's another increase of 1 unit. We could say 1 increase for y, 2 increases for x. And then we see again, x goes up by 2 units, and this time y goes down by 1. It goes from 8 to 7. That's decreasing by 1 unit. So from the third to the fourth row, the slope is y loses 1 as x gains 2. Now at the beginning we saw a constant rate of change, but as soon as we see one pair of rows that does not have a constant rate of change compared to the rest, we know this function won't be linear. It's not going to make a straight line on the graph. This is not a linear function, something we could call a nonlinear function, because rate of change is not constant.